back to exercise 3, solving these quadratic equations by completing the square. Let's take them one at a time. So on the first one, you should have gotten x equals negative 3 plus or minus square root of 5. That's because subtract your 4 over, complete the square on the left, take half of the 6, you get 3. 3 squared, you get 9, add 9 to both sides, and then factor and then take the square root. On number 2, subtract that 8 over, complete the square, take half of the 10, you get negative 5. Square in that, you get 25, add the 25 to both sides. Factor it, go ahead and take the square root, you get x equals 5 plus or minus the square root of 17. And number 3. Number 3 is one of those that you have to divide by 2 since everything is even. I went and added the 14 over and then divided everything by 2. Once I did, it made it a lot simpler. Take half of that middle term, you get negative 1. Square it, you get 1, so you add 1 to both sides. Factor it, take the square root. On this one, whenever you go to factor it, or take the square root, you get square root of 8. Remember, square roots, you want to try to put them in simplest form, so that one became 2 square root of 2. And then finally, on number 4, I went ahead and divided by 3 to begin with. And it doesn't matter what step you do it in, I just went ahead and did it right there. Add the 6 over, complete the square, take half of the 4, you get 2, add the, or square that and get 4, add the 4 to both sides. You get finally x equals negative 2 plus or minus the square root of 10. Let's just take a second. Take a second and look at every single one of these answers. Negative 2 plus or minus the square root of 10, 1 plus or minus 2 square root of 2, 5 plus or minus the square root of 17, negative 3 plus or minus the square root of 5, and let me scroll back to even to this one, 6 plus or minus I square root of 14. See some sort of pattern? These things are conjugates. Whenever you solve quadratics by completing the square, that's what you get. You get some those things, some conjugates. Okay, so let's try one where you have an odd middle term. Ouch. So now we're going to have some fractions in there, but hey, don't worry, we can handle this. Still do it exactly the same way. X squared minus 9x plus blank equals, and we need to subtract this 20 over here, so minus 20 plus blank. Complete the square, take half of this, I get negative 9 halves, keep the fraction, square it, 81 over 4, square top, square bottom. Added 81 over 4 to the left, so add it to the right. 81 over 4. On the left, this factors as x minus 9 halves squared is equal to, now that needs a common denominator, it's going to be 4, so 4 times 20 is 80, so this is negative 80 over 4. Adding those up, 1/4. Take the square root of both sides. X minus 9 halves is equal to, plus or minus, you take the square root of the top and the square root of the bottom, that gives you 1/2. Then finally add this 9 halves over, x equals 9 halves plus or minus 1/2. Alright, those are pretty easy to add up, so let's just go ahead and do it. If I have 9 halves plus 1/2, that's 10 halves, which is 5. 9 halves minus a half is 8 halves, which is 4. Well, I've got 2 whole numbers. What this means is that I could have done this thing by factoring. Let's see if we could have done it by factoring. Did we just waste a whole bunch of time here? Open up our 2 set of parentheses, make it equal to 0. X times x gives me x squared. These two have to multiply up to 20. So how about 4 and 5, and they both have to be negative. Look at that. That one gives me x equals 4, and that one gives me x equals 5. Won't always happen like that. It won't always be that you could have solved it by factoring, but that one did. So here are 2 of them for you to try now by whenever they have a odd middle term. An odd middle term. Give it a try. Pause. All right, let's take a look here. Solving these quadratic equations by completing this square. Were these your answers? All right, over there on the left-hand side, I take half of the 3. Oh, add the 5 over first, of course. Take half of the 3 halves, square it, 9/4. Keep it as a fraction. Add 9/4 to both sides. Then factor and take the square root. And I can break up the square root of 29 over 4 as the square root of 29 and then 2 on the bottom, plus or minus, don't forget that, and then subtract over the 3 halves. So final answer, negative 3 halves plus or minus square root of 29 over 2. Notice you could combine it like this. Take a look. You could write this as x is equal to negative 3 plus or minus the square root of 29, all of this over 2, because they have a common denominator of 2. Okay. And if you ever worked with the quadratic formula, you may recognize like that format. Quadratic formula will give us answers like that. And the reason why is because a quadratic formula is made from completing the square. Anyway, over here on number 2, subtract over my 13. Take half of that 7, negative 7 halves, square it, 49/4, keep it as a fraction, add it to both sides. Whenever I combine these two, I need a common denominator, and I'm left with negative 3/4, which means whenever I go to take the square root, I'm going to have an I there, and break up the square roots top and bottom, and then finally add the 7 halves over. So x is equal to 7 halves plus or minus I square root of 3 over 2. Okay, one more problem type. And that one is, well, what if I have a number out front like this one, 2x squared minus 12x plus 7, but not everything's divisible by 2. So this is the way we're going to try this. We're going to take this 2x squared minus 12x and just go ahead and subtract that over just like we've done before, so minus 7. Now I need to get rid of this 2. I can't actually divide everything by 2, it's going to make a fraction over there. As a matter of fact, you could do it like that, but I'm going to show you this other way because in our next unit, not in our next section, but our next unit, we're going to have to put in a quadratic equation in vertex form, and this is the method that we're going to have to use. So I'm going to leave the 2 here. I'm just actually going to factor it out. Factor it out of these 2 terms. So inside I'm going to have x squared minus, and then I factor out a 2 from this, 6x plus blank, close those parentheses, and then write down the other side, minus 7 plus another blank to complete the square. Okay, now let's complete the square as usual. Divide this by 2, and I get negative 3. Square that sucker, and I get 9. And you might think that you're going to add 9 to this side as well, but you're not. Chop. Let me get rid of that. The reason why you're not is because you didn't really add 9 to both sides, or to the left side. You added 2 times everything in this parentheses, which means 2 times 9. You actually added 18. And that's the tricky part. So you don't add 9 to the right side. We're going to be adding 18. Let me just go ahead and write that in a different color. There we go. Plus 18 from this plus 18. Now let's finish this off as usual. 2x minus 3 from that middle term squared is equal to, adding these things up, I get 11. Okay. Divide both sides by 2. X minus 3 squared equals 11 halves. Take the square root of both sides. X minus 3 is equal to plus or minus. Now I'm going to break this up. Square root of 11 over the square root of 2. I can't have the square root of 2 on the bottom, so I'm going to have to rationalize it, multiply square root of 2 on the top and the bottom. And when I do that, I'm going to be left with, let me come up here, x equals, I'm going to go ahead and add the 3 over. Hopefully combining these steps isn't going to confuse you too much. I just added the 3 over. Still have plus or minus. And now when I clean up this square root business, I have the square root of 22, multiplying those together, over 2. So here's the trickiest ones of the bunch. Whenever you have a number, a coefficient in front of your x squared that all the other ones don't divide into. In order to deal with it, you're going to factor it out of just the terms that have the x in it. All right? And then whenever you go to add something to both sides to complete the square, you have to multiply, you have to distribute it through so that you can take that into consideration whenever you add it to the other side. All right? So here are 2 problems for you to give that a try on. Go ahead and pause it and try them. All right, let's look. Voila. Okay, so on number 1, factor out the 3 after you subtract that 41 over. You're just factoring out of the first 2 terms. And leaves you with x squared plus 8x. So you complete the square on that, take half of that, 4 squared is 16. But you didn't really add 16 to that side. You added 3 times 16, which is 48. So add 48 to the other side. Go ahead and simplify, and then it becomes a problem just like the ones that we've seen before. Divide, take the square root, and then simplify. Over here on number 2, I did the same thing. I took out the 1/4. Now here's the tricky part. Whenever you are taking out a 1/4 of this x, when I'm factoring it out, it has to be a 4 here. 1/4 times 4 gives me that 1 that's right there. Or I should say 1/4 times a negative 4 gives me that negative 1 that's right there. Okay, and then complete the square on that. Take half of that, negative 2 squared, I get 4. But I didn't add 4. I really added 1/4 times 4, which is 1. So I add 1 to the right side. Now, when I simplify, it becomes more like one of the other ones, except I have, whoops, 1/4 right on the outside, so I can just multiply both sides by 4 to get rid of it. I do have a negative square root whenever I take the square root of both sides, so I have to make sure I have an I. And then a square root of 20, it does simplify, we get 2 root 5. Whoa, 2 root 5, not 2 root 2. Look at that. Let's fix that up real quick. 2 root 5. Ta-da! All right, that concludes our lesson here. One objective, completing the square, solving quadratics by completing the square. And that picture pretty much is showing us exactly what we're supposed to do. You take the middle term, you take half of it, whatever you get, you square it. That's what you're going to add to both sides of the equation. All right, here's your assignment. And if you see Rowan's quote down here, I heard that a whole bunch over the break because Rowan really liked to see the green thing and the blue thing and the purple thing over and over again. And that's the little squares being assembled. It was pretty cute. All right, see you in class.